Superconductivity is the property of certain materials to exhibit no electrical resistance at extremely low absolute temperatures. Let's consider an example to better understand this. Imagine you have a toy train set with incredibly smooth tracks. You give its engine a little push and it starts moving. Once it starts, it keeps going around the tracks without stopping or slowing down, and without needing any additional push from you. Sounds pretty amazing, right? This is very similar to how superconductivity works. When certain materials are cooled below a specific temperature, known as the critical temperature, they are able to conduct direct current electricity without any electrical resistance. Such materials are called superconducting materials, or simply superconductors. Different materials have different critical temperatures. Since there is no energy loss, theoretically, electric current in a superconductor can last forever. However, researchers have observed that the current lasts for only a few years in real-life experiments. Superconductivity was discovered over a century ago, on April 8, 1911, by Dutch physicist Kamerlingh Onnes. He was experimenting with the element mercury, which, interestingly, is the only metal that exists in liquid form at room temperature. During one of his experiments, he observed that when he cooled mercury to negative 452 degrees Fahrenheit, just a few degrees above absolute zero, its electrical resistance vanished completely. This groundbreaking discovery became known as superconductivity. Initially, Onnes experimented with gold and platinum before switching to mercury, as the latter was readily available in its pure form. Several years after this discovery, other metals like niobium, lead, and tin were found to also exhibit superconducting properties. At the time of its discovery, scientists understood the effects of superconductivity, but they didn't understand why or how materials became superconductors. This puzzle was solved in 1957, when three physicists at the University of Illinois proposed the BCS theory, explaining the microscopic mechanism behind superconductivity using quantum mechanics. In a normal material, an electric current passes through when negatively charged particles or electrons move through the material's lattice-like structure. However, when a superconducting material is cooled to below the critical temperature, these electrons become paired in what they called Cooper pairs. These pairs then move through the lattice structure without any resistance, making the material a perfect conductor of electricity. These three scientists won the Nobel Prize in Physics in 1972 for this discovery. Brownie points to you if you can name these scientists in the comments below. It was previously thought that superconductivity could occur only near absolute zero. However, in 1986, Swiss scientists found that certain materials, such as copper oxides combined with other metals, especially rare earth barium copper oxides, like yttrium barium copper oxide, can act as superconductors at higher temperatures, reaching almost negative 280 degrees Fahrenheit. These materials are known as high-temperature superconductors. Superconductivity has a wide range of applications in various fields. For instance, superconducting coils are used in MRI machines in hospitals and medical laboratories. These powerful magnets, made from superconducting coils, can produce strong magnetic fields without overheating due to their zero resistance. This is crucial for conducting safe and efficient MRI scans that are essential for medical diagnostics. Another application of superconductivity is in maglev trains, which use superconductors to create powerful and stable magnetic fields that allow the trains to float above the tracks and propel them smoothly and silently at very high speeds. Superconducting magnets are also used in particle accelerators, such as the Large Hadron Collider at CERN, to accelerate and steer elementary particles like electrons to nearly the speed of light. These particle accelerators provide us with valuable insights into the realm of subatomic particles and offer clues related to the origins of the universe. All in all, superconductors are a groundbreaking advancement in material science. Their unique properties open up transformative possibilities for technologies such as magnetic levitation and lossless power transmission, with potential applications across many industries.